Right, for our second video, we're going to start off with one kind of review concept and some examples, and we're going to learn some new concepts then and go into examples of those ones. So let's get started with this here. We have the central angle, which is just an angle whose vertex is at the center of a circle. So obviously it would be this angle here, AOC. So because the vertex is right here, the center, that would be called a central angle. Now the measure of the central angle is the measure of the arc. So if this was, say like 50 degrees, we'd say this arc is 50 degrees. If it was 80 degrees, this would be 80. If it was 30, this would be 30, and so on. So those are always going to be the exact same measure. So using that as an example here, we need to find x and y. Y in this case is this arc measuring from here all the way around to here. Almost kind of looks like a Pac-Man. And x is this central angle. Now, if this arc is 114 and the central angle x is always going to be the same as that arc, then obviously x is 114. Now to find y, this other arc, remember that a circle is going to have 360 degrees all the way around it. So we'd take 360 minus this 114 to get y. So 360 minus 114, y has to be 246. So that would be our x and y for that example. Next one, we're looking at inscribed angle. This one should be kind of a newer concept. This is an angle whose vertex is on the edge of a circle. So notice in angle ABC, B is our vertex, and it's right on the outside of this circle. So kind of as a point of measure here, something to remember, the measure of the inscribed angle is half the measure of the arc. So if this was, say, 60 over here, this would have to be 30. It's always going to be half of it. Same thing if this was, let me change those up to, let's say 90. This one would be 45. I have to get rid of that 0, 45 degrees. It's always going to be half of it. Now another way to look at that is the arc measure is twice the inscribed angle. If the inscribed angle is half of the arc, then the arc is twice the inscribed angle. So if this was 20 right here, twice that, this would have to be 40. So it all kind of, it depends on your reference point. If you're looking at this one first, then you double it to get this. If you're looking at this one first, you take half of it to get this. Okay, so let's use that in our example here. We need to find x, y, and z on this circle. So first one we'll look at, right here we have x is an inscribed angle, and its arc measure over here is 100. So how would we set that up? We'd say x is half times, or half of 100, so x equals 50. So that one was pretty simple. We found our x pretty quick there. Let's look over here. This one, the inscribed angle is 34. This angle. So y, the arc measure, would have to be twice that, or double that amount. Y equals 2 times 34, or twice 34. So y equals 68. So we have x and we have y now. Now to find z, z is this inscribed angle. To find z, we would need to know this arc, this missing piece right here. Now to find that, remember the whole circle is 360 degrees. We've got 62, 100, y we found out was 68, and 76. So we can add all of these up, subtract it from 360, and we'll find this arc measure. So if we start that process, 360 minus 62 minus 100 minus y minus 76. Well, again, we found out that y was actually 68. So we'll plug that in there. When we subtract all of that out, we'll get 54 in the end. So we know that this one is 54 degrees as an arc measure. So how big is z? Remember, z is that inscribed angle, z is going to be half of 54, so z is 27. So now we have our x, our y, and our z for this example. Moving on here, in this one, we're actually looking at what's called the tangent chord angle. I don't think this was discussed in any of our previous lessons, so we're going to go over this really quick. A tangent in a chord will always make an angle that measures half of the arc that is made. So what does that mean? If we do this tangent in red, remember this tangent will only touch the circle at one point. This chord, I'm going to make it in blue, goes like this. Notice how these two make two angles, one over here and one over here. I'm going to draw them in, oops, I want marker. We'd have one big one over here and just this angle, this smaller one here. That's what we're looking for, is this angle x. Now this angle is always going to be half of this arc measure. So if we can find the measure of this big arc right here, we can find the measure of this angle x. So how would we go about finding that? We'll get rid of those. If this is 254, we should be able to find this arc by subtracting it from 360. So 360 minus 254 is 106. So we'll write in that this arc measure is 106. Now to find this angle x, it's going to be half of that arc. So we would say half of 106 is 53. So this angle x is going to be 53 degrees. Again, if it helps, remember it's a degree symbol. In fact, all of these are degrees, 360 degrees, 106 degrees. This angle x is 53 degrees because this arc measure is 106 degrees. Similarly, if we've got, again, here's our tangent line. Draw that one in red, going from H to D. It only touches the circle once and then continues on. Here is our chord. I'm going to do this one in blue again, going from D all the way to W. The angle it makes is 52 degrees, so we need to find this arc measure. So what would this measure be in degrees? Now again, like before, this is kind of our formula for it. This angle, the HDW, is going to be half of, or half times, the measure of this arc. Angle equals half of arc. Okay, only with this tangent and chord thing. So if I wanted to move these around so that I get the measure of the arc all alone, how would I get rid of multiplying by a half? Well, I could multiply both sides by 2 to get rid of it. It's the same as saying dividing by a half. Dividing by a half is the same as multiplying by 2, which we'll cross that out and put a 2 times this on this side, so it's 2 times this angle equals this measure. 2 of this equals this whole arc. So, plugging things in here, this measure was 52 degrees, so it's 2 times 52 degrees equals this arc. 2 times 52, 104. So again, this is degrees. 104 degrees is this whole arc measure. Got another example here. Again, this is the inscribed angle x. This arc measures 76 degrees. So x equals half of 76 degrees. So that means x has to be 38 degrees. Again, we can always write in the degree symbols to make sure we remember we're looking at the number of degrees. This isn't like 76 centimeters around the outside. All right, we got our last example then. If angle EDG equals 85, and again we can call it degrees, 85 degrees right here, we need to find the measure of the arc GDE. So we want this arc around the outside, G to D to E, we want to know that arc measure in degrees. So to find that, we need to know the measure of this inscribed angle from here to here. To find that angle measure, remember for an inscribed quadrilateral, the opposite angles are always supplementary. So if this is 85, then 180 minus 85 would be 95. So right here we've got 95 degrees. So if this is 95 degrees, how would we find the arc measure here? Well, we would say the measure of GDE, this arc, is going to be 2 times that 95. So, pull this away. Measure of GDE equals 190. So this whole arc is 190 degrees. We can always, again, write that degree symbol in if we want. And that should conclude our last video.